0. So I'll move this out of the window. So welcome to the video tutorial on using Docker to deploy a cloud stack for geospatial big data. So first of all, the source code is on GitHub. In our lecture, there is now number 6, Spark demo. Let's look at the files over here. So what you can now see is a single source code file, sp.py. Let's look into it. This will be the program we are going to execute over Amazon Web Services. As you can see, this is a Python file and there's some libraries here, some related to Spark. Spark is the big data framework we're going to use, and some related to the data type we are going to work with, which is ply for our 3D laser scan data. So this line extent is just the extent of the data set. We will use this in the end for projecting things to keys. Just remember that we know beforehand the bounding box of all of the data. And now the data set is just given as a list of URLs. You see that we can just download all of these files. Well, for now, let us just uncomment this because it overrides the variable dataset with a small dataset consisting only of 3 files, so that we can work with a smaller set of data for development. Now a subprogram scanply given an URL is defined here, and what this does basically is to first create a temporary file. This might be on any of our computers in the cluster, and this temporary file is now there are 10 tries of downloading URL to the temporary file. And we have to retry it sometimes because the web server providing the ply data can be quite unfriendly. When we boot this software on a cluster, then all requests will be time synchronized. They will come exactly more or less at the same time. So it could be that 1 or 2 requests simply don't work. Let's look. So when it's successful, we will end the for. So now we can read in the temporary file, which now contains the ply data downloaded, and we just use NumPy to create a matrix containing the x, y, and z coordinates. Okay, this shouldn't be there, right? So we should do this only once. This was just an error. I will correct it. Okay. What we now do is what we already did in the tutorial. We scan for candidate trees with a very simple rule. So a real program would do something more sensible here, but we're just looking into the big data techniques. So what this does is just scanning for scanning the data on the third column, which is the Z column, for values greater 110 and smaller than 112. And this is something we have seen usually consists or is related to trees or to building boundaries. The roofs are usually higher in the dataset and the floors lower. Well, we select from the trees exactly those that have this property by just putting the conditional here for selecting the rows of the data, and we return the data. What we could do is remove the temporary file, but I don't think it's useful because we will use temporary machines anyway. So we will later get a machine that will be removed afterwards. If you're using this on private machines, think about whether you should delete this temporary file. Going on, we have now 2 functions here, the function key and the function dkey. They form a pair. So given a point p, we calculate an integer or a floating point x. So when you only look at this expression, this means that we subtract the left bounding box x coordinate and divide everything by the width of the bounding box, so that for all points inside the bounding box, this is the x coordinate scaled to 0, 1, and we multiply it by 1024. The same we do for y, just with the other coordinates. and we now create a string consisting of 4-digit integers, the integer of x and the integer of y, which essentially truncates everything. So this will usually be 0 to 1024, but shorter things are given zeros in the beginning, and this will be the same for y. The function dkey just is the inverse operation of that. Given a string k, we split the string with a minus, and we give names x and y to both parts, and we return the integer of x and the integer of y. So now x and y are strings, right? So here the integer of x and integer of y is the integer of a floating point number. These are the integers of a string, but nevertheless we return the coordinate as a pair. So, and now we are ready to do everything we want. So first, this connects to the Spark cluster and sets the application name to trees. Sorry, we have to get the indentation right. Then it outputs the data set, it outputs some information on what's going on. And this is, the first trick, the first thing with Spark. So when you have data in your local program, so now we have the array data set, you can call parallelize on the Spark context, and it will distribute the data set over the cluster. And now we want to execute some functions where the data resides. And therefore the Spark API gives a number of functions like flat map, like reduce by key. We will use some of them, and you can look in the documentation to see all of them. But what we do here is, after we have distributed the data set, we execute, so we map to the data the lambda x scanply x, which essentially means for every entry in the data set on the node where the entry has been parallelized, we take the entry, which is temporarily called x, and give it to our function scanply. So essentially, dataset is a set of URLs. The URLs go to all of the machines, and for each URL on the machine where the URL has been distributed, we are going to download the file, right? And the result of that is a RDD, resilient distributed dataset. So this essentially gives us the ply data, the point data, distributed across nodes. So just to check what's going on, we will output the count, so the number of lines or the number of rows in the data, just to see that loading was fine, right? So then we are going to do a simple MapReduce on that. So we call this counts because we're going to do word count with points. What we're now doing is we take all the points, note that they are in our DDS and that they are already distributed across the cluster, and we map to the points the lambda here, which sends each point s to the key of s and a 1. So the key of s is the function key we defined above, and the nice thing is that this function will be available on all worker nodes. This is something that Spark takes care of. And once we have generated these pairs, we will reduce by key. So we will just take all the points that have the same key. So these are all the points that have the same x and y coordinate, right? We will take them and just count on the second part of the key, which is this lambda. Given a pair AB, the result will be A plus B. Okay. Now, what we will do now is that we call collect. So this is the point where the distributed dataset counts. So RDS was distributed, and we're just using Spark API, so everything is distributed afterwards. And now we are just collecting the counts into a local object. So now result is just a local Python object, and what we're going to do is, we will just turn keys into coordinates. So this, what we're doing is for every x in the result set, we will take the x and y coordinate as given by dekeying the key and add a tuple with the x of 1, so the right side of the pair, which is the number, and adding tuples in Python is just concatenation. So we will get the x, the y, and the count. Yes, now we have x, y count. And what we are doing now is that we generate a matrix M with 1024 by 1024 size, and we will just, say plot, rasterize all the information. So the matrix of the x and y coordinate is going to be the count. Now we're just saving this to out.npy because we don't want to do graphics on the cluster. So let's go through it again. Once again, look here. We connect to Spark. We are just going to load the dataset and count it. We're just doing some simple map reduce. We map every point to the pair point, comma 1, and we reduce by the keys so that we count essentially all points with the same key. And then we collect this, so we get it back to the master node, to the node where we are executing this actually. And then we need to, translate the keys. So now we have pairs consisting of a key, which contains the x and y coordinate, and the number. And what we're doing here is just to create x, y number and put this into the matrix, setting the matrix values from the count, which will be saved, right? Good. So far, this is our Spark program. You can look around at the internet for other examples, but we're going to look more into how we get this running on a real cluster. So, okay, let's look again for the files here. So now interesting is the Docker file. So what we define in this Docker file is quite simple. We just take a Spark distribution from my account. So let's just ignore how we get Spark into Docker. And we will run pip install ply file on this, which means that the Python library ply file will be installed into this image. We will need that because we are going to load plies. And then we add the source code sp.py to the root directory of the container. That's nice, right? How do we go about this? Of course, we have to build this. Docker build dot, so this directory, and we have to give it a name. Let's call it Spark demo. Okay, you see that it's successfully built. It will take some time on your computer because it will first download the Spark distribution and it will then actually run this step 2, but here the step 2 was already prepared, so it has just been found. Great. So now that we have it, we have to log in with Docker Hub. You need an account for that. And we will just upload it. Docker push Spark demo, right? We called it Spark demo. Spark demo. Okay, now you see that kind of everything is already online. So this will quite take some time when you have to upload everything. Okay, let's wait for it. Okay, well, so now we can use any Docker-enabled computer on the internet to run Spark demo. But as we are going to do some development also, I have two things now. Two things are left. Okay, three things. There's this make png.py. We can just look at it. It's nothing special. It just loads the out.npy that was created, and it just generates a JPEG out of it. So, and now we have two Docker Compose files. Let's look at the first Docker Compose file. These Compose files just tell us how Docker services relate to each other and how they should be executed. And for Spark, we need a master and a set of workers. So what you can see here is basically that there is a master which takes the image mvernat/demo, which is of course not good. We should edit it because we gave another name to it. Let's see. So we're going to use the image that was just created, Spark demo. And the master will of course just run the Spark master. You can look at the internet what this actually does. The hostname will be master, and we will mount the current directory dot to /data. Note that this is for development and will be run on the local computer, so that I can run this sp.py and at the same time edit it on my host. Now there is just some configuration going on, some ports to be exposed. 8080 is possibly one of the most important ones here, which is just the Spark web interface. We will see that. And you see that here's some deployment which has been commented out. Essentially, this block of deployment, we will see this later again, says that the master should go to the manager node. And now the worker is defined, which is more or less the same. Again, we have to correct this for the newly created image. It's going to start a worker, and the worker will connect to the master. Master has the name master. The name has been set above, host name master. Okay, and then we will have here some configuration. We have a connection to master. We will expose port 8081 for the worker. And again, here is a deployment block, which says more or less that the worker should run on each node except the manager node. But this block has been commented out. So such a compose file can easily be used with Docker Compose. You have to download Docker Compose, and you need to run a working Docker, right? But we can just run Docker Compose up. This now creates a worker and a master. And let's take a browser. Right. Localhost, because we're just running locally, colon 8080. This is the Spark master interface, and we see that there is one worker, no cores are being used, there are no running application, and there are no completed application. We will just keep this window open and go here. Now we need another window, right? Because here is just Spark is just running there. So now let's take this window, a bit larger. So what we can do now is we can edit whatever we want here, sp.py, but it's already ready. Then you can use docker ps to find out all the nodes that are currently running. And you see that we have 06 Spark demo worker 1 and 06 Spark demo master 1. And we can now exec into the container, which is just like entering the container. So we want to have a shell inside the container, and this is something we will do. And -it just says that we want to use it with a keyboard interactively. So now we have to tell him where we want to execute to. Spark demo master 1, and we want to execute bash. This gives us command prompt inside the container. That's ls, right? We can also go to /data, and you see here's the sp.py. This is just the mount that we have specified in the docker compose.yaml. So what we can now do is we can try to run sp.py. Remember that we have set up this small data set. So how does this work? We just Spark submit the py file. Let's see. A lot of information is being given, and here you see that here some things are going on. Interesting is kind of that you see starting task 0, starting task 1, finish task 0. So this is already distributed between the worker and the master. Okay, and it's going on, and should now complete. Let's just scroll up a bit. You see that there is our small data set as we had it, and you see everything is working, right? Let's just scroll. I'm just scrolling around looking for the output, right? Here, this output comes from our script, right? These are, the first thing is where we have some print data set, and then we print distributed loading. Then some distributed operations take place, which you can see on with all these info. And then let's look for the first line without info. There should be some more output in between. And as you can see, this info is quite useful because it also contains errors, but we can also take the freedom of saying that we will pipe everything onto the first. So this is a trick. 2 greater and 1 means that we will take the error stream, which is stream 2, and attach it to the standard output. So all usual messages and all error messages will go to this stream, and this stream can be filtered with grep. And when we now do a reverted grep on info, this will remove all lines that contain info. And as we don't need kind of this stuff, this output, now we see really the output of our program, more or less. Distributed loading, so now it's just loading from my web page, right? Or the 3 files, or the three URLs. And now it's starting MapReduce, and you see here, this is the count. This one is the count. Okay. MapReduce is going on, so we're just counting points in the grid. Note that this is not actually very fast on this laptop. So now the result is denormalized, and what we would expect is now that here there is this out.npy, which is true. We can close this by just entering exit. Now we are kind of out of the container again, and you see that I'm on my host again, Martin at Gauss9, and you can see that the out.npy is actually here. And now on my computer, so this is not on the Spark, this is not inside Docker, I can run python make png.py, and I can look at the out file.jpg that has been generated. And I don't know whether this will come out in the video, but we've only used a very small part of the dataset, and here on the top you see some structures. Okay, this is something you should see. So these are points that have been selected. Black is something empty. Great. So everything worked on my local computer. Let's just clean it up. So we don't need this terminal anymore. It was just being used to submit the job. We're back at the terminal where the master and the worker are running. So this is where Docker Compose is actually running. And I can press Ctrl+C, and you see that it takes care of cleaning up. And I would say that we go that we have done everything right. Good. So let's now look into Docker Compose avs.yaml, because we will have to edit some part of this. So the next step will be to run this across a set of machines at Amazon. Here, the same error we called the image Spark demo. This is more or less the same config. The main difference is that the deployment constraints are actually there. So this says that the master will be there once, namely at the manager node. We will see later how we find out which node is the manager node. Again, the image for the worker will be Spark demo, and it will be deployed globally, which means one container per physical node, and it will go on all nodes except the manager node. Right, so now that we are going to do this on the cloud, we will have to upload our changes to GitHub. So git status will tell us that I have just been changing some files. Okay, as you can see, more or less all files. So let's just edit sp.py, because we want to use the full data set when we are on AWS. So we can just comment out the small data set. Now the data set will be the large data set, and we will also see this in the output. So I just saved this file, and yet now we have to just commit all these changes. Updates for running on Amazon. Git push origin master. We will just upload it to GitHub. And this way we will be able to just use it from an AWS machine. So how do we go about AWS? First of all, you need an account. Let's go to the internet. AWS management console. Okay. So you can just go there and log in. Oh, you need a good password. And it would be great if you are not using my account for this. Okay, so logging in. We can go to the dashboard and you see that basically there are 3 key pairs. We can delete all of them. This is just cleaning up from previous experiments. And going back to the dashboard, I will explain you a bit about this. So here we will have running instances and here key pairs, and each running instance will have a key pair, and we won't take care of the work of setting up Docker or computers or anything. Therefore we have the tool Docker machine. But you have to download and install Docker machine, and we will just create our machines using Docker machine. We will have to look for the exact command of doing this because we will need large machines. I have to think about where I have this. I think it has been some part of last project. This is not what I want. Possibly this one. Right, this is going to create a single machine. But so I'm a bit lost. So we will have to ask Google for Docker machine specify instance type. So the point is that we want to have a specific instance type, and we can use this for that, right? Okay. So when you want to use Amazon Elastic Compute, there are several instance types. And an instance type is essentially a question how the computer is configured. So we can also Google for IVS pricing, because this is one of the best web pages for getting an overview of the instances. So what we're going to do is on demand, so we will want our computers to be available at. So, and now you see here the instance types. I will make this slightly larger for the video. So you see that, for example, for 1 cent per hour, we can get a micro machine, which has 1 virtual CPU and 1 gigabyte of memory, and only elastic block storage. So when we remove the machine, the hard disk will vanish too. So what we can use for our project is possibly this one, T2.medium, which gives us 2 CPUs, 4 GB of RAM, and it costs 5 cents per hour. So yeah, we can do that. So these would be quite too small, not enough memory, but T2.medium should be good, because then it's possible that we also see how it schedules with the main memory. Right, we could also take larger, 32 GB or 256 GB. This costs $3 per hour, but this would just make our big data problem trivial. So let's take T2.medium. How do we do this? Well, we can just close this. I've just been looking for this. We can just run Docker machine. And now we go back here and see. So the command will be create. The driver will be Amazon EC2. There are drivers for other cloud providers and also for VirtualBox and whatever, but we are going to use Amazon now. And we can, it already knows the access key and the secret key stored on my computer. We can use this flag, Amazon EC2 instance type, Amazon EC2, oh sorry, there's no dash, EC2 instance type, and then we can just go over here. We set T2.medium. t2.medium, and now it only needs to have name. Let's call it AVS01. So host already exists. That's a problem. We need to give it better names that I have not been using before. Let's call this Spark01. Okay. This tool now just goes to Amazon and creates an instance and installs Ubuntu and Docker, and we will get a perfectly running machine in just a few minutes. We can take the time in between to look in the management console. Let's refresh it. We should now see one running instance, one volume, one key pair. Let's look at the running instance. So we're just running and it's just initializing. That's not surprising. We already have IPs for that. The name is Spark01 and it's a T2.medium located in the US East region. Okay, let's go over and look what happens. So the machine is available. The machine has now Ubuntu installed and we're just going to install Docker. Right, this part of the video will take some time, but we can make it faster by just taking a new terminal and copying the command for creating the machine. The machine should have another name, so we have to copy it without the new line. So we can go here and just create Spark02 with the same specification. A new terminal, creating Spark03. And possibly 4 nodes are enough for now. Let's look at, well, Spark01 will be our master, and it's already quite working. It's installing Docker now on the remote host. And you see that the other installations here are also working. Provisioning. This is just waiting for the machine, provisioning, right? So we can go to the web console again. And when you're doing this, you should definitely have a look at the web interface here, because this is where the cost comes from, right? Now we have 4 running machines on AWS. And so this usually doesn't take so long. Okay, Docker has been installed. So now it's just copying certificate files so that we can go into this machine. And just a few moments, just some Docker configuration. Yep. In a few moments, this machine will be fully set up. Wasn't really hard work for us. Mainly we were just waiting, right? Okay. So as the tool tells you now, you can just look at Docker machine environment Spark01, which gives a lot of information. This is, for example, the Docker host if you wanted to use Docker locally. This is the certificate, but we don't want to use that. We want to just use Secure Shell and go into this machine. So Spark01. Docker, this is of course wrong. We have to use Docker machine, Secure Shell Spark01. So now you see our computer on the internet, Ubuntu at Spark01, and we have to use sudo -s to become root, because the pre-configuration of Docker is not the way that the user Ubuntu can use Docker. But what we now want to do is check whether Docker works. Okay, we can enter Docker, and now we are going to create a Docker swarm. We will just make an overlay network of all our nodes. And the swarm consists of a master, which will be this node, swarm init Spark01, will be the master of this swarm. And we now get a command with which all other nodes can join the swarm. So we will just copy this. So now, where does this machine go? This is not good. Let's make it smaller. So this is our master. Let's take the next machine. Spark04 is ready. Docker machine SSH Spark04. Now we are on the machine, we get root, and I will just use the command that I copied from the right terminal to make this part of the swarm. And by the way, this will be with workers, but we will never use this terminal again, because we can use this worker just from the swarm master node. So I will just exit here, and close the window. So the next machine we want to enter our swarm is Docker machine secure shell to Spark 3. Okay, the same here. We copy the program, we join the swarm, we can close this window. And here again, the machine is ready. Docker machine, I make it slightly larger, Docker machine, SSH Spark 02. Getting root and joining the swarm. Right, so now we are left with the master of the swarm, which is this one. And we can just look at all the nodes. We have all here, right? This is a swarm of a lot of nodes. And now we can deploy our program. How do we go about that? Well, first of all, we have to go to GitHub. Because now it's time to grab our software. And we have this Spark demo here. And what we now need is basically this docker compose -avs.yaml. Remember that we put all the software already into the Docker Hub. So on GitHub there's this raw link here, and if we click it we get a URL here, which is great. This is how we can download it to this machine. So I'm just going to download this. Yeah, just to show it to you. Now we have it here. And now we can just use a docker stack deploy compose file docker compose avs.yaml. So this will be more or less the same we docker compose up, but it will use the full swarm we created. Okay, there is a problem. There's a problem that okay, we didn't give it a name. So it claims that we need a name. Right, we named it Spark. So now a lot of things are working. We can look with Docker PS of what's going on. Docker service list is better for now. We see that this is just going to spawn a global worker, 3 replica. Let's think about it. So we said this should be on each physical node except the master, and we have 1 master. So let's not just hope that it's going to boot within the next time. We can just also look at the logs or ps docker ps -a. Well, I don't see the rel. Now, it just downloaded everything from Docker Hub, and now it's running. And when we now do docker ps, that's what I wanted to show you, we see that on this physical machine there is a Spark master running. And, well, let's take a new terminal and let's docker machine secure shell into, for example, AWS, into, how did we call it? Spark 03. We will just go to some of the workers, do a docker ps, and you see that here a worker is actually running. So our deployment is fine. So let's look at whether everything works really good. We now need the public IP of the master node, which is Spark 01. Here is the public IP. We can just copy this IP and we can just put 8080 behind, and we see our Spark cluster with 3 workers. Everything is fine. Okay. Now we've just set up the complete Spark stack. And now we're just doing more or less the same we did before. We will just exec with a terminal into the master, right? The Spark master is here. We can use the container AD. We can just take the start and we will start bash. Now we are inside the container and everything looks like it looked before. For example, here is sp.py. The only difference is that the directory data is not mounted because it's not there and it is not specified like that. But what we can do now is spark submit sp.py. But before we do that, let's go to martinwerner.de, because that's where the data comes from in the end, and we can just look at it. Okay, I'm just going to the Apache logs and we will look at the access log of my computer. So I just make a white terminal. So here we will see who is accessing which file on my web page. And now I will just Spark submit this program. You see, as before, the information. You see, well, there was this dataset line, and we did something wrong because this is the small dataset. And you see that it starts downloading the dataset, and you also see that it downloads from different nodes, right? Here's 184, 184, 135. Well, let's scroll down here. What's happening? Everything fine or something wrong? So the easiest is, okay, so first of all it was much faster, and let's look. There is this out.npy, so everything is fine. Let's remove this out.npy and let's actually add it. So this is now difficult because we don't have a good editor here, but let's shortly edit sp.py because we have activated this small dataset. Let's insert a hash here, a hash here, a hash here, a hash here, and let's write this file, let's close this file, and let's Spark submit again. So now this is working, and we can now just refresh this page and you see, okay, there is one stopped application. Something is running around 6 cores. Note that we don't have a worker on the master, which is just, we could do that, but for now we just don't want to have that. So we have 6 cores working, though every machine has only 2 cores. And we're using 3 GB RAM. And this is just a limitation we set up in the configuration file. You see that the first execution was 23 seconds and that it's now already running longer. And you also see that a lot more data is going to be downloaded from my webpage. So now it's just time to refresh here from time to time. By the way, you can also look into the workers, what they're actually doing. Okay, these links are not working because the address is internal. So what we could do is we could look up a worker here. This is the IP address of a worker. Let's copy it. This doesn't work. But we can use the keyboard for that. And then we can just put it here. 8881. Okay, something is wrong with that, but doesn't really matter, right? Let's look at where the workers are. 8881. So this doesn't work as expected, but I don't mind. Well, so after 21 seconds, kind of something has been done. And you also see how the things are going on because it shows you the lines. So we can, for example, look at what line 98 says. For example, we can use GitHub for that. This is beautiful, but the wrong file. So sp.py, as we have been using it, on line 98, around line 98, is counting. So we are actually just in the MapReduce, and it's just finished one of the tasks inside this MapReduce stage. Collected 99 is working. So now I guess we are done with the out.npy. Great. So you see that this was quite fast. This was really 1 gigabyte of data. And we can now check in the Spark. Yes, this is wrong. In the Spark web interface, we can check that the application is completed in 3 minutes. Okay. So now we have the result here. And now we need to get this result. And we can... So the simple thing we can now do is to put this onto some server. I will just do this now, but possibly you will put it into something else. So we will use the port 1234 and we will use again martinwerner.de. Right. This copies out.npy to my... Oh, doesn't have... we are inside the container and it doesn't have SSA. So this is of course wrong. What we now need is to go out of the container and to docker cp, and now we can copy this file by giving again the container number. This is ad slash not sp.py, but how's the output called? It was out.npy. So now we are on the machine, on the AWS machine. I copied it out of the Docker container into the machine. Now it is here. And now I can just put this to my server, into my home directory. Okay, we need a large P in this command. You see that not everything's perfect when we're just screencasting. There's a typo again. So we will put the out.npy to my web page. It asks for a password, which is a good thing. Yeah, you see now that we have put this 8 megabyte file there. So I will now leave the cluster untouched. I will just exit from the cluster, and remember that now 4 machines are running and eating money. But we want to look at whether everything is fine, and therefore we have to pull the data on port 1234 from my web page. We get this out.npy. So okay, we should copy it here. Ask for password. What's about that? Out.npy permission denied. For some reason it was not able to write out.npy here. Somehow this is owned by root. So we will just remove it being root. And now we can just move the out2.npy to out.npy. and run, make png.py, and look at the output, which contains now much more interesting information. Right there is some stuff, and here is some stuff, and everywhere there is a bit of stuff. Well, yeah, this is what we were just doing. We were just filtering points with a specific height, and we can just collect this in 3 minutes from all the machines. Now let's close all the windows here. Let's look at the management console. Now we still have all these machines running. And the good news is that we can just terminate them again here. Docker machine rm spark 01. Yes, I want to delete it. Spark 02. Yes, I want to delete it. Spark 03. Yes, I want to delete it. Spark 04. Yes, I want to delete it. And let's now look again. Refresh this page, and it will show us that it's shutting down all the machines, so that the money is not counting anymore. So now we have used the full big data stack for crunching a gigabyte of data and looking into a quite useless program, but nevertheless it's a program. And I hope that this helps you when you need to run your own projects. Just for completeness, let me tell you that this Docker file, which is based on the other Docker file mvarno.ds/spark, and the Docker file for this image just contains Spark and R, and that you can find it on GitHub too. So well, this should be everything. We can now exit. We can also exit here, and we can just refresh here again. Let's refresh this. Let's look at what happens here. Everything is terminated. Doesn't have IP addresses or anything. It will soon be completely removed. We can also go to the dashboard and see that we have only 4 key pairs left. This is just a bug in Docker machine. Doesn't correctly delete the key pairs. So we should do this manually on the Amazon side. Well, that's everything, right? Thank you very much.